jungle.
Sa pagpatay ng virus, tiwala ka ba sa kahit anong alcohol lang? Kailangan tested. Green Cross Alcohol.
Hi guys, I am Joshua Balbuena from BCED 2A. And now, I'll show you and I will discuss the parts of the aromatic hydrocarbons and the uses of inside the aromatic hydrocarbons. So, and now, let's talk about the purposes of the aromatic hydrocarbons. And each of us, we will discuss about the aromatic hydrocarbons and I'll show you some example of aromatic hydrocarbons. So, let's go. So, what are aromatic hydrocarbons? Aromatic hydrocarbons are unsaturated hydrocarbons which one or more planar with a 6 carbon inside the ring. That is what we call a benzene ring. Some of aromatic hydrocarbons contain a benzene ring. In benzene rings, stabilized by resonant pi electrons are delocalized in the ring structure. So what are the unsaturated hydrocarbons? First is the pure hydrocarbons atom attached to the carbon chain than alkanes. Second, alkanes with a double bond. Third, alkynes with a triple bond. Then, we have the saturated hydrocarbons. First is the maximum number of hydrocarbons or hydrogen atoms attached to each carbon atom. The second, alkanes and cycloalkanes with a single carbon-carbon bond, which is the CH2 bond with a CH2 and bond with a CH2. So here's some example of aromatic hydrocarbons. The first is the benzene ring. Benzene ring is an organic chemical compound with a molecular formula of C6 and H6. The benzene molecule is composed of 6 carbon atoms joined of a planar ring with 1 hydrogen atom attached to each. Because it contains only carbon and hydrogen atoms, benzene is classified as hydrocarbon. The second is naphthalene. Naphthalene is an organic compound with a formula of C10 and H8. It is the simplest polycyclic aromatic hydrocarbons and is a white crystalline solid. Also, naphthalene are found in coal tar, crude oil. Also, uses for this manufacture plastics, resins, fuels, dyes, and etc. Also, use this as fumigant insecticide that work by turning directly form a solid into toxic vapor. This process is also called an sublimation. And the third is the trinitrotoluene, more commonly known as TNT or the using for bomb, or more specifically a chemical compound with a formula of C7H5N3 and O6.
Hi mga bata! So this morning, we will be discussing the properties of aromatic hydrocarbons. So I hope you will listen to this video. So I will give you some background on this topic, like what's his history. So when we say aromatic hydrocarbon, I remembered my lolo. So to those person who don't know my lolo, his name is Michael Faraday. He's the first discovered aromatic hydrocarbon. But sad to say, his theory was rejected due to its incapability to explain the known properties of benzene. So, kanong mo daw bino, for example, og na mo tana sa inyo hangalagti ka kaayo, unya, pangutan uni mo, or ngano, or unsay rason, yun dili siya ka-explain ngano. So, did you expect to believe that? Of course not, diba? So, that's what exactly happened to my Lolo Michael. Because he's incapable to explain the properties, that's why his theory is rejected. Aromatic hydrocarbon, or also called as arenes, are compounds that have a 6-membered carbon ring. So when you say 6-carbon ring, what comes into your mind? Correct. It's benzene, the benzene ring. Benzene is the simplest aromatic hydrocarbon with alternating single and double bonds. And because the benzene is the simplest of them all, we should focus on benzene lang yun. Kaya kung sa lahi ta mag-focus, no, lahi ng storya. All substances that have structures and chemical properties resembling benzene are classified as aromatic compounds. So, balik dito sa mangoyabay, no? So, nabayuban sa babae nga tagduha or tagtuloy lang mangoyabay. Unyag ma-discourage, no? So, basta doon nila ang isa, syempre. So, focus din sila sa usa. So, iyang rason, study first, bisan og bakasyon. So, unya kay nakita man sa isa nga, nabastid ang isa, so ano dayon siya nga, ako nalay mo poli ini. And that's what happened to Kikuli. When he discovered that the theory of Michael Faraday got rejected, that's the time when Kikuli proposed that the carbon atoms in the benzene molecules are arranged in a 6-membered carbon with 1 hydrogen atom bonded to each carbon and with 3 carbon-carbon double bonds. And of course, what's the use of being apo? So, dira na ko maingon nga, sige, ako nalang explain. So, that's why this morning we will discuss the properties of aromatic hydrocarbons. When we say aromaticity, what comes into your mind? Yes, it's a property of cyclic or ring shape, flat structure with pi bands in resonance. When we say resonance, it is those containing delocalized electrons. Delocalized means detach or remove. It was helpful because it gives increased stability compared to other geometric or connective arrangements with the same set of atoms. When you can imagine or you can picture out the benzene, what did you observe? Yes, the first one, it's stability, and the second one, it has the same arrangements. What you can say to the left, you can also say to the right. Who can answer why carbon atoms is high compared to the hydrogen? In benzene, how many hydrogen? Yes, it's only have 1 hydrogen atom that attached to each carbon atom. And how about the carbon atom? How many? You are right. It composed of 6 carbon atoms joined in a ring. So, I will repeat my question, no? Why carbon atoms is high compared to the hydrogen? Yes, because carbon is an especially noteworthy element in living systems. Why carbon is worthy? Because there is a uniqueness of carbon. The carbon atom has 4 valence electrons. Because of this unique configuration, it is easier for the carbon atom to share its 4 electrons with another atom than to lose or gain 4 electrons. Because each carbon is identical, they all have 4 valence electrons, so they can easily bond with other carbon atoms to form long chains or rings. In fact, a carbon atom can bond with another carbon atom 2 or 3 times to make double and triple covalent. In short, si carbon atoms, bisan asa gid siya ibutang, so na siya gamit. There are 2 reaction substitutions that you observe. The first one, electrophilic, and the second one, nucleophilic. So, baka maybe you can ask, no, teacher, what is the difference between the nucleophilic or the electrophilic? Okay. Nucleophilic substitution reaction is a chemical reaction which involves the displacement of a leaving group by a nucleophile. And then, electrophilic substitution is a chemical reaction that involves the displacement of a functional group by an electrophile. So it means Nucleophile donates its electrons, while electrophile accepts its electrons. So I hope you can learn in this video, and I hope you can watch the next video of mine. Thank you!
Hello everyone, good day. My name is Aromatic, Best Ed 2A. In today's video, I will going to further discuss about aromatic hydrocarbon. First, what is hydrocarbon? Hydrocarbon means compounds of carbon and hydrogen only. Hydrocarbons play a key role in our daily life. You must be familiar with the terms LPG and CNG used as fuels. How many different compounds do you think two elements can form? You might guess only a few compounds are possible. However, thousands of hydrocarbons are known, each containing only elements of carbon and hydrogen. Hydrocarbons are of different types, depending upon the types of carbon-to-carbon bonds present. They can be classified as three main categories: saturated, unsaturated, and aromatic hydrocarbons. Saturated hydrocarbons contain carbon-to-carbon bonds and carbon-to-hydrogen single bonds. If different carbon atoms are joined together to form open chain of carbon atoms with single bonds, they are termed alkanes. On the other hand, if carbon atoms from a closed chain or ring, they are termed as cycloalkanes. Saturated hydrocarbons contain carbon-to-carbon multiple bonds, double bonds, triple bonds, or both. Aromatic hydrocarbons are a special type of cyclic compounds. You can construct a large number of models of such molecules of both types: open chain and closed chain.
Hello ladies and gentlemen, today we are going to discuss about aromatic hydrocarbons, examples of aromatic hydrocarbons, properties of aromatic hydrocarbons, reactions of aromatic hydrocarbons, polycyclic aromatic hydrocarbons, the uses of aromatic hydrocarbons in our day-to-day living. Examples of polycyclic aromatic hydrocarbons: naphthalene. One common example of these polycyclic aromatic hydrocarbons is naphthalene. These compounds are said to be pollutants. Naphthalene has 10 carbon atoms and 8 hydrogen atoms, so its chemical formula will be C10H8. Phenanthrene is a polycyclic aromatic hydrocarbon with formula of C14H10 consisting of 3 fused benzene ring. Phenanthrene has 14 carbon atoms and 10 hydrogen atoms. Anthracene. Anthracene is a solid polycyclic aromatic hydrocarbon with a formula of C14H10 consisting of 3 fused benzene ring. Anthracene has 14 carbon atoms and 10 hydrogen atoms. Since we already know about the examples of polycyclic aromatic hydrocarbons, now we are going to talk about the uses of aromatic hydrocarbons in our day-to-day living. Methylbenzene. Methylbenzene, which is an aromatic hydrocarbon, is used as solvent in model glues. Methylbenzene has 7 carbon atoms and 8 hydrogen atoms. Naphthalene. Naphthalene is an important item in the production of mothballs. Trinitrotoluene, or TNT, is a very important aromatic hydrocarbon which is widely used for explosive purposes. Phenanthrene. Phenanthrene is an aryl hydrocarbon used for the synthesis of drugs, dyes, and explosives. Phenanthrene has 14 carbon atoms and 10 hydrogen atoms.